Assalamu alaikum. In this series, Mr. Omar will guide you through some practice problems to cover all items included in the coverage issued by Emirate Schools Establishment, E.S.E. This is part 6. Have a fruitful time.
Assalamu alaikum warahmatullahi wabarakatuh. We'll come back again. Now we will go back to the forces. A gymnast of mass 55 kg hangs vertically from a pair of parallel rings. If the ropes supporting the rings are vertical and attached to the ceiling directly above, what is the tension in the rope? Now, the question asked me about part A. Let us draw the free body diagram for this gymnast. Here is the gymnast. He is affected by force of gravity, Fg. Then, as a reaction, the ball will push it up, N, and the other ring will push again up with the same force, N. So here we have, since it is equilibrium, F net equals 0, N plus N minus Fg equals 0, so 2N equals Fg, and N equals Fg over Fg mg over 2. So N equals mg over 2. Mass is 55. Times G, 9.8 over. The answer would be 55 times 9.8 divided by 2 is 269.5 newtons. And we can say, I'll name this force as tension. This is the tension in each rope. Now, question number 2. If the ropes are attached so that they make an angle of 35 with the ceiling, what is the tension for each rope? Now, we are in different situation in which we have the ceiling like this, and here is the gymnast. Here, first rope, angle 45, and here is the second rope, and the angle again it is 45 against the force of the gravity downward energy. Now we need to put x and y axis. This is x, and that one is y. Since the two angles of the two ropes are equal, then we can conclude that the tension in each rope is equal to the other one. But let me, don't be hurried. Let them T1 and T2. This angle is 45, so this angle is 45, and that one is 45. Now make the resolution for tension. Here we have T1y and T2y. The x-axis T1x to the right and T1y to the left. Now T1x, sorry. Now the resolution for T1x equals T1 cosine 45, and T1y, T1 sine 45, T2x equals T2 cosine 45, T2y equals T2 sine 45. Now apply the equilibrium in x-axis. F net on the x-axis equals 0 because we have equilibrium. Then T1x to the right minus T2x to the left equals 0. So T1x equals T2x. T1x it is T1 cosine 45. T2x is T2 cosine 45. We can cancel cosine 45 since it is not 0, and we get that T1 equals T2. So in this stage we prove that T1 equals T2, which is obvious because the two ropes makes the same angle with the ceiling. Now we need to find this tension. We need to find tension. Now let's go to y-axis. On y-axis also we have equilibrium. So F net on the y-axis equals 0. What we have on y-axis? We have 2-1y plus 2-2y up and Fg downward. So T1y plus T2y minus Fg equals 0. T1y it is T1 sine theta plus T2y it is T2 sine theta equals Fg. We agree that T1 is T sine 45 plus T2 is also T sine 45 equals Fg. So 2T sine 45 equals Fg, then T equals Fg over 2 sine 45. Fg it is mVg, which is 55 times is the mass 55. Yes, 55. G 9.8 over 2 sine 45, and that's it. 55 times 9.8 divided by 2 sine 45. The answer is 381. When the angle is closer to the ceiling, the tension is increased, which will be the answer for the third problem. How does the tension in the rope changes as angle theta between the ceiling and the ropes becomes smaller and smaller? Theta becomes smaller and smaller, then the tension become larger and larger. And it is obvious by the equation T equals Fg, which is constant, 2 sine theta. So as theta decreases, the sign will decrease, which means the tension will increase because it's inversely proportional with sine theta. A source sign of mass 4.25 is hung by two wires that each make an angle of 42.4 with the ceiling. What is the tension in each wire? It is the same as the situation for the gymnast in part B. T1 equals T2. We will not show that. It's obvious. It is a best paper question. So it is not multiple choice. This is the sign. This is X and this is Y. FG. First tension. Second tension. So T1X equals T1 sine theta or sine theta sine theta because this angle is theta cosine theta. T2x equals T2 cosine theta. T1y T1 sine theta. T2y T2 sine theta. Now because of these two components and we have equilibrium, we will find that T1 equals T2 and let it be T. So this is T sine theta and this one T also sine theta. Now go here for y-axis. Also we have equilibrium with F net on y-axis equals 0, T 1y plus T 2y minus Fg equals 0. Again, as discussed before, 2T sine theta equals Fg. So T equals Fg over 2 sine theta. Fg is m times g, 2 sine theta. The angle is 42.4 and the mass is 4.25. 4.25 times 9.8, 2 sine 42.4. And you can easily find this answer. .5 multiplied by 9.8 divided by 2 sine 42.4. Anyway, a load of bricks of mass 200 kg is attached to a crane by a cable of negligible mass and length of 3 meters. Initially, when the cable hangs vertically downward, the bricks are a horizontal distance t 1.5 from the wall where the bricks are to be placed. What is the magnitude of the horizontal force that must be applied to the loaded bricks without moving the crane so that the bricks will rest directly above the wall? A load of bricks of mass 200 that is attached to a crane by a cable of negligible mass and length L. Initially, when the cable hangs vertically downward, the bricks are a horizontal distance d, 1.5 from the wall, where the bricks are to be placed. What is the magnitude of the horizontal force that must be applied to the load of bricks without moving the crane? Okay. Again, read it. Okay. Now, the load is vertically hanged, and the wall is here. If we apply a force on the weight in this direction without moving the crane, this load will be on the wall here. The distance from the object to the wall is 1.5 meter, and the symbol is D, capital. The length of the string L is 3 meter. Now, when the load reaches the wall, it will make an angle of theta, and we can find theta easily by using D and L. Tan theta, opposite over adjacent. The opposite is D, the adjacent is L. This is tan theta. This is tan theta. Now, let us draw a free body diagram for the object, or the load. We have force to the left, to the right, sorry, F, and the weight is downward. And here, attention in the string, T. And this angle is, as we mentioned, theta, which is this angle here. So if we draw x-axis and y-axis, this angle should be theta. Now make resolution for the tension. Here is Tx, and on the y-axis Ty. And since there is no motion, so we have equilibrium, we can say that F net total equals 0. That means F net on x-axis equals 0, and F net on the y-axis equals 0. On the x-axis we have F to the right minus Tx to the left equals 0. So F equals Tx. The other side, for F net on the y-axis, we have Ty upward minus Fg downward equals 0. So Fg equals Ty. What about Tx? The angle for the tension here, the angle, it is with the y-axis. So the y-axis take cosine, and x-axis take sine. So here T sine theta, and here T cosine theta. This is an equation, this is another equation. To solve these two equations simultaneously, divide them on each other. So by dividing equation 1 over equation 2, what we will get? Here we have F over this F over FG should be equal T sine theta over T cosine theta. That's it. Easy like that. Now you can cancel T with T and change sine theta over cosine theta with tan theta. F it is unknown, Fg is m times g, then F equals mg tan theta. But as we mentioned before, tan theta is d over L here. So F equals mg tan theta equal d over L. And that's it. Substitute. The mass is 200, L3 and D 1.5. Then 200 times 9.8. D it is 1.5 over 3. 200 multiplied by 9.8 multiplied by 1.5 divided by 3. The answer is 980 Newton with to the x-axis, right or left. So, yeah. Now, a piñata of mass m8 kg is attached to a rope of negligible mass that is strung between the top of two vertical poles. This is the first pole and this is the second pole. The horizontal distance between the poles is d. This distance is d. And it is equal to meters. And the top of the right pole is a vertical distance h higher than the top of the left pole. So here there is difference in the elevation between them. This distance is h and h is 0.5. The piñata is attached to the rope at horizontal position halfway between the two ropes. So this distance from here to the piñata is half the way. It's d over 2. And this one also it is d over 2. We know d, so this is 1 meter and this is 1 meter. I want to make it clearer. This is the halfway. This distance is d over 2. D it is 2 meters. D over 2, 2 over 2 it is 1 meter. And this is also 1 meter as well. Okay? I don't think it's okay. Now, the piñata is attached to the rope at horizontal position halfway between the two poles, and the vertical distance is below the top of the left pole. So this distance is S. This one is S. Find the tension in each rope. Okay. For the tensions we need angles. This angle is be alpha and this angle, let it be beta. This distance is S, is also here S. This is also S. Now, we can find alpha and beta. Tan alpha, as in the graph, it is S over D over 2. S is equal 1 meter, D over 2 it is also 1 meter. Then alpha equal tan inverse 1, which is 45. We found alpha. Now for beta, tan beta equals the opposite to the beta, it is this distance, h plus s, over d over 2. This is d over 2. Now let us put the numbers. H, it is 0.5, s it is 1, over d over 2 is 1, 1.5. Then beta equals tan inverse 1.5. Which is 6.3. Now the question becomes very easy. Since we know the angles, let us draw the free body diagram. This is x-axis and this is y-axis. Here is the piñata. Here we have tension P1 and here we have tension P2. This angle is beta and this angle is alpha. We have the weight in this direction. I will solve this question easily without resolution. It is a new method. Its name is Lamy's rule or law of sines. It is the same. So I will not make resolution for these forces as before. But you need to find the angles here. What is the angle between T1 and FG? It is beta plus 90. And beta it is 56.3 plus 90. So it is 146.30. Now, what is the angle between T2 and the weight? This angle is alpha plus 90. Alpha it is 45 plus 90. So it is 135. Now, what about this angle? This angle will complete the circle. So it is 360 minus 135 minus 146.3. Because all of these three circles, three angles make one full circle. 360 minus 135 minus 146.3. It is 78.7. Now, Lamy's rule or law of sines, law of sines or Lamy's rule. Start with Fg over equals T1 over equals T2 over, and we need now to put the signs. What are the two angles around T1? It's 78 and 146. So 135, it is the opposite to T. So put here sine 135. What is the opposite angle for T2? Here is T2, and the opposite angle of it is this angle, 147.3. And the opposite angle for the weight, it is 78. If you understand it, it is very easy, and we can say that we are finished. So, how can you decide the opposite? This is T1. Around it we have two angles, 78 and 146. So the opposite of it is 135. Okay? Again, for T2. For T2, we have two adjacent angles. This is T2, 78 and 135. So the opposite one is 146.3. That's it. Okay. Now we can follow two paths. This path or this one. Following the first one, FG over sine 78.7 equals T1 over sine 135. Multiply by sine 135, you are left with T1 equals FG sine 135 over sine 78.7. That's it. We multiply by sine 135 here, and we are left with T1. Now, how much FG? The mass is 8. FG equals M times G. 8 times 9.8. 8 times 9.8, it is 78.4. So put for FG 78.4 sine 135 sine 78.7. So this should be multiplied by sine 135 and divided by sine 78.7. The answer is 56.5. T1. Now for T2, go to the other path, the second one. T2 over 1463 equals FG sine 78.7. That means T2, bring this here, equals sine 146.3 over sine 78.7. Substitute for FG 78.4 sine 135 sine 78.7. 146, this 146.3. 44.4. So we solve these forces without resolution and analyzing on X and Y. Practice this well, you will be satisfied. Now for this question, it is a repeated question. We solved it before. You remember that the skying. So you can go back and see what's up. Yeah? We need to draw free body diagram. This is the incline. This angle is given. Here is the weight. Normal. Friction. Motion. Then make x-axis and y-axis. Then make resolution for FG as we studied it before. Go back to that question and try to practice it again. This is very important. Now, a large ice block mass M equals 80 kilograms is held stationary on a frictionless ramp. The ramp is at an angle of theta 36.9 above the horizon. If the ice block is held in place by tangential force along the surface, so this force is tangential to the surface of the ramp, find the magnitude of this force. I think it's easy now. For part A, we have a ramp with an angle of theta, and we have here ice cube. Immediately we'll draw x-axis and y-axis. Put the weight, make the distortion of the weight Fgx and Fgy, then the normal force on the y-axis. After that, the question told us there is a force tangent to the surface held the ice block stationary. So the force should be in this direction against the weight. And it is tangential to the surface of motion or the ramp as mentioned in the question. So this is A. Now we don't need to find the normal force. Why? No friction. No need to find the normal force, except if the question asks us to find that. But if the question doesn't need a normal force and we have no friction, no need to solve for it. Now we have equilibrium on the x-axis. So on x-axis, we usually put F net on x-axis equals m times a, but the object is stationary, so the acceleration is 0. Now the forces on the x-axis are Fgx to the positive minus FA to the negative equals 0. So FA equals FGX, and FGX is mg sine theta. M is 80, G 9.8, sine the angle 36.9. 80 times 9.8 times 36.9. The answer is 471 Newton. This is for part A. For part B, the same ramp, but instead the tangential force, we need a horizontal force. So the force is parallel to the horizontal. Redraw the question. This is theta. Here is the isoblock with the x-axis and y-axis. Again, we need not to find the normal force. Here we have Fg downward, and we can make the components of G. This is Fgx, and this is Fgy. Now we held the block by a horizontal force. This is the horizontal. This angle should be theta. And then this is FAX, and this is FAY on the x and y axis. Now, F net on x axis equals m times a, and since we held the object at stationary, this is 0. What are forces in the x axis? This is the x axis. We have Fgx in the positive direction and Fax in the negative x direction equals 0. So Fax equals Fgx. Fgx, it is mg sine theta. Fax, now the angle for Fa, it is between Fa and the x-axis, so the x-axis is the adjacent. So Fax, it is Fa cosine theta. Then Fa equals mg sine theta over cosine theta, mg tan theta. Sine over cosine is tan. Now substitute 80 times 9.8 tan the angle 36.9, and the answer is 80 times 9.8 times tan 6.9 is 589 approximately. A skier starts with the speed of 2 meters per second. This is the initial. And skies straight down a slope with an angle of 15 relative to the horizontal. The coefficient of kinetic friction between the skies and the snow is 0.1. What is the speed after 10 seconds? Okay, Here is the inclined surface. The angle is 15. A is here. X-axis and Y-axis. Weight. This angle is 15. Here we have FGX and FGY. And no other forces acting on the object except the friction. Since the motion is downward, the friction would be up on the incline. Now we need to find Fk, so we need the normal force. The normal force on y-axis. This is the normal. Now on y-axis, F net on the y-axis equals 0. The normal up minus FGY equals 0. So the normal force equals FGY, which is mg cosine theta. Here we find the friction, Fk equals uk times n. So it is uk mg cosine theta. Now we will go to x-axis. On x-axis, we have F net on the x-axis equals m times a. On the x-axis, we have Fgx, the positive side, minus Fk equals m times a. Fgx, it is Fg mg sine theta, minus Fk, it is mu k mg cosine theta. These are equal m times a. You can factorize mg and left with sine theta minus mu k cosine theta equals m times a. You can cancel m both sides, and you have here the acceleration. Now we need the velocity after 10 seconds. And we have the initial velocity, 2 meters per second. Easy now. V final equals V initial plus A times V. V initial plus the acceleration is sine theta minus mu k cosine theta times g times V. This is V final. V initial 2 plus sine, the angle is 15, minus mu k is 0.1, cosine 15, g it is 9.8, and the time is 10 seconds. Substitute to find the answer. 17.9.
I hope that this video has enriched you more. In the description box below, there are links to both a PDF document for answers and the other videos in this series. This is the end of part 6. See you in part 7. Salam.